Hello, in this video, I'll demonstrate the equations. I'll demonstrate the questions 4a, 4b, 5a, and 5b. Firstly, I'll verify the x-intercepts and the vertex form of quadratic equation by changing the values of a, b, and c. Then I'll show you how these parameters affect the graph and finally explain how accurately determined the equation best fits the targeted curve. For A, for questions 4a, I entered values of a2, b3, and c equals to -1 into the start section. The spreadsheet automatically calculates the x-intercepts using the quadratic formula. The results are approximately 0.281 and -1.781. The orange graph crosses the x-axis exactly these two values, confirming that the calculations are correct. If I change the values of a, b, or c, the x-intercept changes intermediately because the coefficients changes the root of the quadratic equation. 4b, vertex form. The spreadsheet also converts the quadratic equation into the vertex form for the equations of y equals to x squared plus 3x minus 1. The vertex form is 2. Y equals to 2 bracket x plus 0.75 bracket square minus 2.125. The coefficient 2 remains outside the bracket because it controls the vertex stretch of the value. Positive 0.75 shifts the graph 0.75 units to the left, while negative 2.125 moves the vertex downwards. The graph shown matches the vertex position. And now I shall show you the coordinates that I found matches the orange curve to the blue curve. It is negative 0.32, 1.2, and lastly 6.3. These coordinates that I have found they have guessed matches the orange curve to the blue curve. So when I change the A, the graph becomes steeper or wider. The positive value opens the parabola upwards, while the negative value opens it downwards. And when I change the B, the graph shifts sideways because it changes the axis of symmetry. When I change the C, the graph moves downward, up, and down because it is the y-intercept. By adjusting these three coefficients together, the orange curve gradually becomes a close match to the targeted curve. Then for 5b, instead of estimating by trial and error, a more accurate method is to use several precise 1 second for the curve. I first record accurate coordinates from the blue curve such as these points. Then I substitute each point to the quadratic equations. Negative 0.61, negative 0.61, 1.364, and lastly 5.325. These are the computed values. Thank you, and that will be all.